the last thing I wanted to mention is, what if you have initial conditions? And for this, let's solve x prime equals ax, where a is 10 minus 4, 12 minus 4, but with initial condition 5, 7. And as usual, the first steps are to find the eigenvalues and eigenvectors, which again, I invite you to look in the notes. And eventually what you find is we have the eigenvalue 2 with eigenvector 1, 2, and the eigenvector 4 with, so eigenvalue 4 with eigenvector 2, 3. And that gives you the solution. Step 4, solution. So x of t is c1 e to the 2t times 1, 2 plus c2 e to the 4t times 2, 3. Same thing as before. Eigenvector goes with the eigenvalue. And now let's do the initial condition. And you will see it's just an extra step. Initial condition. So in this case, x of 0 becomes c1 e to the 0 times 1, 2 plus c2 e to the 0 times 2, 3. Which becomes c1 times 1, 2 plus c2 times 2, 3. And remember, we want this to be 5, 7. So really, all we need to do is solve this system for C1 and C2. So solve really C1 plus 2C2 equals 5, and then 2C1 plus 3C2 equals 7. Now, what I'll show you is a really cool linear algebra way of doing that. So let's solve it by what you call Gaussian elimination. Because what's nice is we already have those vectors 1, 2, 2, 3, 5, 7. Let's put them in what's called the augmented matrix. 1, 2, 2, 3, 5, 7. And kind of the idea is we just want to turn this 2 into a 0. So that we want 0. And we can do this by what's called those row operations, meaning we can switch 2 rows, we can multiply a row, or we can subtract a multiple of one row to the other one. So here, to make this 2, 0, we can subtract 2 times the first row from the second one. So 1, 2, 5. And then, so in this case, 2 minus 2 times 1, 3 minus 2 times 2, and 7 minus 2 times 5. And we get 1, 2, 5. 0 minus 1 minus 3. Let's simplify this a little bit. So let's divide this by minus 1. And then we get 1, 2, 5. 0, 1, 3. And then the next step is to turn this 2 into a 0. And we can achieve this by subtracting 2 times the second row from the first. And we get, so 1 minus 0, so 1 minus 2 times 0, 2 minus 2 times 1, 5 minus 2 times 3, 0, and then you keep the other row. And then you have 1, 0, 1, 0, minus 1, and then 0, 1, 3. And that's what you want. Ideally, you want the left-hand side to be 1, 0, 0, 1, because the cool thing is this automatically tells you that C1 is minus 1 and C2 is 3. It might look like magic, but is what's called Gaussian elimination. And so in the end, x of t now becomes minus e to the 2t 1, 2, and then plus 3 e to the 4t times 2. I might ask you to put the solution in a certain form, but here, since nothing was specified, this is a perfectly acceptable solution. And if you want, I can show you a picture of what this looks like. So this is kind of cool. Think of this as an asteroid, which sort of comes from 0 as t goes to minus infinity, and then goes through the initial condition, 5, 7. You can't really see this in this picture, but that just blasts off towards the northeast side. I mean, how cool is that?